until we'll finish up then. Okay. All right, so let's talk a little bit more about hypothesis tests and we saw some hypothesis. We've already seen quite a bit of hypothesis tests and things like that. Okay, so I just want to kind of, I don't know, point out things so you know when you're dealing with a one-sided test or two-sided test or all of that good stuff. Okay. So again, the null hypothesis will always have an equal sign. All right. And then the alternative will have not equal or greater than or less than. Okay. Not equal means you have a two-sided or two-tailed test. And these are one-tailed tests. And you pick these based on how the question's written. Okay? Pick the sign, or yeah, pick the sign based on you might see something like, is this evidence that something, something, something? Or test the hypothesis that okay? And usually it'll be like that, the average or the proportion or whatever it is that you're dealing with, that will be in there. And then somewhere along the way, okay, if you see words like has changed, is different, not the same, something like that, generally these mean you're going to use a not equal sign. Okay. If the question says something is greater or larger, has increased, gotten taller or whatever, you know. More. Exactly. Any of those types of words, you're going to use the greater than. Okay, and then anything, you know, less, smaller, decreased, etc., etc. I think you guys get the idea. Use the less than sign in the alternative. So far, so good, yeah? Okay. All right, the other key is, are we dealing with proportions? Or means? So, the 100% foolproof way, okay? So, to be absolutely sure, just ask, are we dealing with categorical variables? Okay, and if it's categorical variables, we're dealing with proportions. Or numeric variables. This means we're dealing with means. And I feel like if you go through this course, and if you can't tell the difference between a categorical variable and a numeric variable, I feel like you shouldn't pass the class, okay? And this is absolutely key. But I know some of you still have trouble telling the difference between a categorical variable and a numeric variable, especially when it's written in a problem, okay? And so I'll give you some hints as things that will help you identify whether you're dealing with proportions or means, but these aren't 100% foolproof, okay? There could be some, I don't know, slightly different situations where these tips or keywords don't hold up, okay? But in general, okay, so to be absolutely sure, ask, are we dealing with categorical or numeric? That's the only way to be absolutely sure, okay? But in general, these also hold true, okay? In general, if you see proportion or percentage, then you're dealing with proportions, okay? Generally you're dealing with proportions. There are some instances where that might not be true, but in general that's general true. Okay, so if you see counts of a category, okay. Alright, well, I mean, if it's a category, it's going to be proportions. Okay. On the other hand, if you see average or mean, okay, then you're dealing with means. Or if you see a standard deviation. Also dealing with means. Okay? So in general, as you're reading the problem, if you see those things appear, then you're probably dealing with the proportions or the means. Okay? But again, to be absolutely sure, just ask, am I dealing with a categorical or a numeric variable? Okay, this holds true probably like 99% of the time, 95% of the time. But there are weird scenarios, so I hesitate to say this is always true. Okay, and here's the other thing, alright? If you're dealing with proportions, you will always use the z-table, okay? Z-table always. And if you're dealing with means, t-table always. Okay. So means, you're going to use the t-table, proportions, the z-table. Okay? So that should help you keep track of all of these things. I've also made a study guide, which is on the same page where you can check out the practice final. I think it's very good in terms of getting you to identify the different parts. Okay. But you know, some students don't like it as much. Other students love it. You know, your mileage may vary. So. All right. So let me just kind of put kind of a little bit of an overview here. All right. So just we have four types of hypothesis tests. Okay. We have one sample hypothesis tests for proportions. Is this about halfway? And then I've got two sample hypothesis tests for proportions. Okay. And then so I'm gonna put all four up on the board here. So I don't know how you want to set up your papers, your notes. And I've got one sample hypothesis test for means. And then two sample hypothesis test for means. Okay. All right, so let's go through each of these. All right, so here your hypotheses. You get your null hypothesis and your alternative. And here, the null hypothesis is P is equal some number. Okay, so I'm going to just put in like 0.30. Okay, but it's just some number here. All right. And the alternative is that P doesn't equal or is greater than or is less than the same number here. Okay, so whatever number is in here, okay, the same number here. So the same number appears right there. So those are your hypotheses, okay? And of course, you got to read the problem to decide what number goes here and whether it's the greater than, less than, or not equal. Yes?
What number does go there? Like the mean in the problem? Or the
Well, okay, so we're dealing with proportions, so there's no mean, right?
Oh,
It's
right.
the proportion that we want to test our hypothesis against, okay? So it says, is this evidence that the proportion in the population is different from 30%? Okay? Do not put your sample proportion here, okay? That's a key thing, okay? Do not use the sample proportion here. That's a common mistake. Do not use the sample proportion. Do not use p hat. P hat in the hypothesis. Okay, so it's always p, and then it's some proportion. It's a proportion that your hypothesis is about, not whatever your sample is. Okay. Our standard error is equal to the p from our hypothesis times 1 minus p divided by n, square root. Okay? And here, use the p, the value, this 0.30, use the number in the hypothesis. Okay. And then our z-score, our test statistic, okay, observed minus expected divided by the standard error. So in this case, what I observed is my sample proportion. What I'm expecting is the p from the null hypothesis. And I divide this by my standard error, which is this value. Okay? This is going to be my z-score. Okay? I look this up. Look this up in the z table. Okay? And then I either take the area to the left or to the right, or I double it, depending on whether I have a one-tail or two-tail test. Okay? Look this up in the z table to get our p-value. So that's the process that we go through for one-sample hypothesis tests for proportions. Two-sample hypothesis test for proportions. Let's talk about that. Okay, so here, our hypothesis is we have two samples, and we're making comparisons about the two samples. So my null hypothesis is what?
Equal.
Yeah. P1 minus P2 equals 0, or I could write P1 equals P2. And the alternative, P1 minus P2 is greater than, less than, not equal to, whatever you want, okay? So just for variety, I'm going to put in greater than 0. Okay. Again, use P's, not P hats. And this number is almost always going to be 0, okay? The number is almost always 0. Or at least in this class, it's always going to be 0, okay? If you take another class on statistics, you might be, maybe it's not always 0. Almost always 0, okay? Okay. And then use P, not P hats. Our standard error is the square root of p hat times 1 minus p hat times 1 over n1 plus 1 over n2, where p hat is equal to the total number of successes divided by total observations. So usually this is x1 plus x2 over the quantity n1 plus n2. This should look very familiar. Here, our test statistic again is what we observed. But here we're observed minus expected over the standard error. What I observed, basically, I'm taking whatever in all of these things, whatever is written in the null hypothesis. I'm just putting hats over these things. So here I got P1 minus P2 in the null. I'm going to do my observed is P1 hat minus P2 hat, okay? And what I'm expecting is 0. So I put in the 0 there. And then I divide by my standard error, okay? And whatever number I get here, I look up in the z table to find our p-value. Now, in general, your p-values should, you know, if you are, if you get a positive value here, you're generally going to be looking to the right, okay? Because you're looking, you're looking in the opposite direction, or into the tails in general. Alright. So now we're doing one sample hypothesis tests for means. Okay? So here my hypothesis, my null hypothesis is what? Is that mu, the population mean, is equal some number. Okay? I'm going to just put in 43. Okay? But whatever number is, okay? This is just, again, some number. And then the alternative is that mu is greater than or less than or whatever, same number here, okay? Put the same number right there. It's not 43, whatever. You got to read the problem to figure out what number goes here and whether you use a greater than, less than, or not equal sign. Again, use mu, not x bar. Alright, my standard error is equal to s over the square root of n. And my test statistic what I observed minus what I'm expecting divided by my standard error. I observed x bar. What I'm expecting is 43 or whatever number shows up in the null hypothesis, and I divide by my standard error, which is s over the square root of n. Then what? I look this up in my t-table. Okay? And use n minus 1 degrees of freedom for the t-table. And I know some of you had a little bit of trouble with using the t-table, so if we need to, we can review that. But you got to be able to use the t-table, otherwise we'll have some problems. It's not all that bad. Alright, and the last one, for hypothesis tests, okay, because we got confidence intervals to cover also. So we got mu1 minus mu2 equals 0. The alternative is that it's not 0 or greater than 0 or whatever, okay? Standard error s1 squared over n1 plus s2 squared over n2. And my test statistic, again, observed minus expected over the standard error. x1 bar minus x2 bar, x bar 2, minus 0 over standard error, okay? I look this up in the t-table, and I use n minus 1 degrees of freedom, okay, using the group with the smaller n. Use the n of the smaller group, of the group with fewer items. And that's it for hypothesis tests. Okay, so we've seen, alright, Alright, we've taken a few weeks to cover all of this, and so now we have it all summarized here, and it's not too bad, right? It's all very similar. You set up the hypotheses, you figure out your standard error, you figure out your test statistic, and you look it up in the table. Okay? And they all follow this same process, same idea, and it's just the way we write our hypotheses changes, the way we figure out our standard error changes. That's about it.
What is the for sure rate for the two simple hypothesis testing?
What do you-
To make sure that we know which one is P1 and which one is P2. Because
Oh,
sometimes that can get confusing.
It shouldn't matter. If you, I mean, for the tests, just to make sure everything's consistent, I'm going to call this group 1 and call that group 2, okay? But if you get your P1 and your P2 mixed up, everything's going to be exactly the same. The only thing that's going to be different is your test statistic is going to be negative, okay? But everything else is going to be the same. And so your tail area, because it's symmetric, is going to be the same. So everything else. So all it changes is your test statistic is going to be negative or positive. Okay. But everything else turns out to be identical. Yes.
What do you mean use the end of the group with fewer items?
Yeah. So we've got two groups, right? We've got sample 1 and sample 2. If sample 1 has 15 items and sample 2 has 13 items, I'm going to use the n of sample 2. So I'm going to use 13 minus 1 and say I have 12 degrees of freedom.
Oh, okay, yeah,
Okay. All right. So let's do all of this. And so instead of hypothesis tests, let's talk about confidence intervals. Okay, confidence intervals for proportions, okay? Form is p hat plus or minus z star times our standard error, okay? Our standard error is the square root of p hat times 1 minus p hat over n, okay? This looks similar to the standard error we use for hypothesis tests, but it's not. What's the difference? We're using p hats, okay? We've got hats rather than the p from our null hypothesis. Z star depends on our confidence level, okay? 90% we use what? 1.645. 95%. 1.96, 99%, 2.58. I guess if we wanted an 80%, 1.28. That's it.
Just to verify, is that times SE?
Yeah.
Okay, thanks.
Z star times standard error. Okay, and then we say I am whatever percent confident that P that the population proportion P is between blank and blank, right? Okay. And so we understand this plus and minus, right? We do the thing plus and we do the thing minus. Okay, so what's my center? The center of my confidence interval is P hat, right? This is my center. This whole thing is my margin of error. This is called my critical value. And this is called the standard error.
Are you going to give us the confidence level and the margin of error?
No, I won't. I won't do that. Okay. Two sample confidence intervals for proportions, not covered in our class. Okay, other classes might cover it, but we didn't do it. You can write to the textbook publisher and say, why don't we cover this? And so they'll add it for you guys. Huh? It's okay.
It's okay.
That's alright, you guys don't want that? Okay, over here.
Are we going to be covering that or
No.
no?
Nah. Surprise! No. I won't do that. X bar plus or minus here, T star times standard error. Standard error, S over the square root of n. T star comes from our T table. Okay. Look up n minus 1 degrees of freedom and the appropriate column for the confidence level.
The appropriate what?
Column.
Column.
The center is x bar, or this is my the estimate of mu, right? Center is the estimate of whatever parameter we're trying to estimate. Okay, again, this is my critical value. Same thing. That's still my standard error. This entire thing, this is my margin of error. And right, I am blank percent confident that what? That the population mean, or population average, okay, and then if I say, do we have evidence that the mean is different from 20? How do we decide what our answer is? So if 20 is within my interval, what do I say? I do or don't have evidence that it's different from 20?
You do.
No, if 20 is inside my interval, I don't have evidence that it's different. Okay? If 20 is not in the interval, I do have evidence that it's different from 20. Right. Okay, and last one. center, or the estimate of the difference, plus or minus t star times my standard error. Okay, and my standard error is that. Use t star, look up t star from in the t table. And then we make our confidence interval this way. How do I decide if I have evidence of a difference or not? If 0 is in the interval, what? I do or do not have evidence that there's a difference between the means. I do not. If 0 is in the interval, there's a difference between the means. And if 0 is not in the interval, I do have evidence. That there is a difference. So that's what we got for. Oh, confidence. Are you tired? I'm tired. Yeah, hungry.
Pizza, Costco?
Huh?
Costco.
I didn't get any Costco pizza yet. They close at 8, so or 6 Sundays.
Still you have pepperoni for that?
I do. All right. Is this good? Questions? All right. Yes. Okay. Okay, I'll have to re-look at it because I'm not sure what prompt you're talking about off the top of my head. I'll take a look. Okay, let's go back to hypothesis tests. Okay, back to hypothesis tests. Okay, what is a p-value? Can you tell me the definition of a p-value? The p-value is a probability.
Observing our data.
It's the probability of observing our data, exactly.
Or something more extreme.
Observing our data or something more extreme. If what?
If you assume the null hypothesis.
Yeah, if we assume the null hypothesis were true, okay? Or if the null hypothesis were true. how do we decide whether or not to reject the null hypothesis or not reject the null?
If it's p-value is smaller than
Yeah, so our
the-
decisions go like this. If the p-value is less than alpha, what do?
Reject.
We reject the null hypothesis. If we reject the null hypothesis, we accept the alternative. What else do we say? We say we have evidence to reject the null, or et cetera, et cetera, et cetera. Anything along those lines. If the p-value is less than alpha, decisions. On the other hand, if our p-value is greater than alpha, what do we do? We don't reject. Okay? So notice I never say I accept the null. Okay? When I talk about acceptance, it only is in relation to the alternative. For the null, it's either I reject it or I don't reject it. Okay? So we don't reject the null. We don't accept the alternative. Accept the alternative just yet. Alright? Accept the alternative. And yeah, we don't have evidence to reject the null hypothesis. Okay? Okay, so there's a couple of things we have to talk about, and this, this next thing is not deeply covered in your book. It's briefly covered in your book, but I think it's an important concept, and I don't want to just ignore it. Okay. So so there are some errors we can make in a hypothesis test, and I'm not talking about errors or mistakes that you guys make in your work. Okay, but these are errors that are inherent to the hypothesis testing process, okay? Errors inherent to the hypothesis test, okay? Okay? And if you think of a hypothesis test as kind of like a trial, right? And if you have a trial, what you want to go for is you want to find out the truth, okay? But we don't know the truth, right? The defense has their side and the prosecution has their side, and they're kind of at odds, and we're trying to understand the truth. So, because the truth is unknown to us, there are just two types of mistakes that a jury can make at the end of a trial. What are those mistakes? So the jury, at the end, they can either choose to say guilty or not guilty, right? Which is similar to rejecting the null or not rejecting the null, okay? So, but there's inherently, because the jury doesn't know the actual truth, and they're just basing it on the evidence and the case that was presented to them, they could make a mistake, right? When they choose guilty, we're hoping when the jury chooses guilty, it means the defendant truly was guilty, okay? But the mistake that they could make is that they've they've decided they declared an innocent person to be guilty. That's a mistake. Okay. The other mistake they can make is that if they choose not guilty, we're hoping that means the defendant is actually innocent. But it's possible for them to say not guilty when the defendant is actually guilty. So they're letting a guilty person go free. Okay. Likewise, in statistics, when we do hypothesis tests, those are the same two mistakes we can make. Okay. Now, there's two types of mistakes, and we don't have creative names for them. We have the type 1 error and the type 2 error. Alright, the type 1 error, this is where we have rejected the null hypothesis. Our decision is to reject the null hypothesis, but the null hypothesis is actually true. So that's a mistake. The null hypothesis is actually true, which means we don't want to reject it, but we made the decision to reject it, okay? Because our data, for whatever reason, made us believe, gave us a p-value that was less than alpha, and so we rejected the null hypothesis.
Isn't that what alpha is?
Yeah, so alpha is the probability of committing a type 1 error, okay? So I'll put that up on the board in a moment. Okay? And type 2 error is the opposite, okay? Our decision is not to reject the null hypothesis, but the null hypothesis is actually false. Okay, so if we think of a criminal court case, the null hypothesis is that the defendant is innocent. And the alternative is that the defendant is guilty. Alright. So, what is a type 1 error in the context of a criminal court case?
No, that they're sending an innocent man to
Yeah.
jail.
Type 1 error is is convicting an innocent person, okay? Or, Okay. And a type 2 error would then be letting a guilty person go free. Okay? Now, we don't want to be making either of these mistakes, right? But if we were forced to choose to make a mistake, like if we had to err on one side over the other, which side would we prefer to err on? Yeah, we would rather let a guilty person go free than convict an innocent person. Okay? At least that's how our justice system is set up, right? In other countries it's different and things like that. But here, we would rather let a guilty person go free than convict an innocent person. Okay? And sometimes when high-profile cases come up on TV, and the person is found not guilty, there's always people getting upset about that. But that's the way our justice system is set up, right? So, in other situations, maybe we would prefer to make a type 1 error over a type 2 error, okay? it all depends. Okay? So, our significance level, our choice of alpha, is actually equal to the probability of a type 1 error. Is equal to alpha, okay? Our significance level. So if we pick alpha equal to 5%, what we're saying is that whenever my p-value is less than 5%, I'm willing to reject the null hypothesis. But how often is my p-value going to be less than 5% if the null hypothesis were actually true? It's going to be less than 5% 5% of the time. Okay, it's going to be, or 5% or less 5% of the time. So the probability that I'm rejecting the null, even when the null hypothesis is true, is equal to alpha. So that's the probability of a type 1 error, okay? The probability of a type 2 error is beta, okay? So alpha is the first letter of the Greek alphabet. It's like A. And then beta is the second letter of the Greek alphabet, so that's B. Okay? First letter is A, second letter is B. Alpha, beta. That's actually where we get the word alphabet. Okay? So we have alpha and beta, probability of a type 2 error. And then we have something called 1 minus beta. And this is known as the power, okay? So whenever I do 1 minus something, that's the probability of what? Starts word with a C. The complement, okay? So 1 minus something, the complement is the event that what? It doesn't happen. It doesn't happen, okay? So beta is the probability of a type 2 error. So the complement of type 2 error is not committing a type 2 error. Okay. What was a type 2 error? Our decision is not to reject the null, but the null hypothesis is actually false. So what does it mean to not commit that? No. To not commit a type 2 error means our decision is
True.
to reject the null hypothesis, and the null hypothesis is actually false. Okay? So power, this is the probability of correctly rejecting the null hypothesis when the null hypothesis is false.
So beta is the complement of what?
Power is the complement of a type 2 error. Yes.
So that would be like convicting a guilty person.
Convicting
Like
a
you
guilty
did, right?
person, right?
Okay.
That's the correct
Got it.
that's the correct thing to do, right? So if your prosecution, if you gotta, like if the prosecutor is very good, we would say the power is high, okay? If the prosecution does a terrible job, right? Like there's hardly any evidence, and they can't, they're just like blah 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 blah. Then the power of that trial would be weak, okay? We would, even if the person is guilty, maybe the evidence that we have is just not going to hold up, right? If it's just anecdotal evidence or something, there's nothing. Someone says, "Oh, I think I saw someone that looked kind of like this person." You know, that's not providing a lot of evidence. Okay. So to increase the power is either you gather more data, you have more evidence, that's going to increase power, or Another way of increasing power is by having a jury that's a little bit too eager to convict someone. Okay, but we generally don't want to do that, right? We generally don't. We tell the jury, make sure you are certain beyond a reasonable doubt, because we don't want to increase their type 1 error. Okay? So that would be the other. Okay, so that's power. Power is
The complement of
a type
powers-
2 error. Okay, so committing a type 2 error is not a good thing. The complement of that would be power. Okay, it's the opposite. Not committing a type 2 error. It's correctly rejecting the null when the null is false.